Hello everyone. In the last lecture, which was the introduction to the environmental science series, we have discussed about the component of the environment and based on those components, I have enlisted the subjects which are going to be covered in the entire series, starting with the subject that is atmospheric chemistry, air pollution and climate change. In this subject, I am going to cover the structure and composition of the atmosphere at the first. So what is the atmosphere? And the atmosphere is basically the mixture of gaseous, dust, water vapors and other particles that envelop the earth, and it is primarily composed of 78% nitrogen and 21% oxygen. So uh, this atmosphere is further divided into 5 major layers and several uh, secondary layers. So on the basis of the temperature and pressure profile, the Earth's atmosphere is divided into various horizontal layers. Each layer has its characteristics and is characterized by the slope of its temperature. Starting at the Earth's surface, these layers are called as troposphere, stratosphere, mesosphere, and the thermosphere. So these layers are divided based on the temperature and pressure profile. We have checked the temperature and pressure profile by going from surface to the topmost layer of the atmosphere, and then based on based on the slope and of the temperature and the pressure profile, we have divided divided the atmosphere into these 5 layers. So starting with the very first, that is the troposphere, the lowest and the most important layer, because almost all the weather phenomena, that is the fog, clouds, dew, frost, rainfall, hailstorms, storms, thunderstorms, and lightnings occur in this layer. Thus, the troposphere has utmost significance to all life forms and ecosystems, because all these are concentrated in the lowest part of the atmosphere. Therefore, the lowest part of the atmosphere, which is the troposphere, is very significant for the life. So what is the extent of this lowest layer of the atmosphere, that is called as troposphere? It is up to the 17 to 18 kilometer, but it varies at equator and poles. At equator, it is about 18 kilometer, and at poles, it is about 5 to 6 kilometer. So on an average, in mid latitudes, the extent of the troposphere is about 12 kilometers. Right? So as we have said that these layers are based on the temperature profile, so we will be discussing the temperature of all these layers. So temperature of the temperature of the troposphere decreases with increasing altitude at the rate of 6.5 kilometer, and reaching about minus 50 degree at the top of the troposphere. So let's revise that. The temperature of the troposphere. The temperature decreases with increasing altitude at the rate of 6.5 kilometer. And at the top of the troposphere, you will see the temperature of minus 50 degrees Celsius. right? That is the temperature with the increase in each kilometer in the atmosphere, in the lower troposphere, right from the surface of the earth, we will see a temperature decrease of 6.5 degrees Celsius. And the other point is more than 80% of the mass of the atmosphere occurs in the troposphere. More than 80% of the mass of the atmosphere occurs in the troposphere. Further, it contains 90% of the water vapors and 75% of the gases. These are the data points which we have to remember forever. So that whenever a question is framed, on these data points, we will be able to answer those questions. So number one is the temperature of the troposphere decrease with increasing altitude at the rate of 6.5 degrees Celsius per kilometer. And the number second is at the top of the troposphere, the temperature is about minus 50 degrees Celsius. And the third point is about 80% of the mass of the atmosphere occurs in the troposphere, and then it contains 99% of the water vapors and 75% of the gases. Finally, the troposphere has another secondary layer in it, that is the planetary boundary layer. So planetary boundary layer is the lower most part of the troposphere, which is about 0 to 3 kilometers. And this planetary boundary layer is influenced by friction, moisture and temperature. So its extent, so the extent of this planetary boundary layer varies with seasons, and varies with the changing day and night, that is diurnal variation, and then the spatial. So the height of this planetary boundary layer varies with seasons. That is, in the summer season, the height will be maximum, and in winter, the boundary layer height will be minimum. And similarly, in the diurnal variation, that is, at the daytime, the boundary layer height will be at its maximum, and at the night its height will be minimum, and it will also vary spatially from one place to another place. So this planetary boundary layer is further divided into laminar layer, which is about few centimeters, and then surface boundary layer, which is about few meters, then the friction layer up to 1 kilometer. This part of the troposphere, that is lower part of the atmosphere, will be discussed when we will study the air quality models, that is mainly the dispersion modeling. So on the top of the troposphere, the tropopause, which separates this layer from the next layer. So as the turbulence in the troposphere stops, the next layer starts, that is the stratosphere. Between the stratosphere and the troposphere, there is a layer called as this separating layer, which is called as tropopause. So let's start the stratosphere. Stratosphere is the second layer of the atmosphere. Height on an average, upper limit of the atmosphere is taken to be 50 kilometer. So the upper limit of the stratosphere is about 50 kilometers. that must be ranging from 12 or 18 kilometer to 50 kilometer. In the stratosphere, temperature in the stratosphere, temperature increases with altitude, reaching -2 degrees Celsius at the top. So, the temperature profile of troposphere was increasing. That is, was decreasing. Now in the stratosphere we have temperature increasing trend. At the top of the troposphere we had the temperature of -50 degrees Celsius. Now it start increasing, and we have got the temperature of -2 degrees Celsius at the top of the stratosphere. So we have an inverse slope in the stratosphere. In the as you have seen that in the as you have seen that is in the troposphere, it was decreasing. In the stratosphere it is increasing, right? So 99% of 99% of the mass of the atmosphere is in 50 kilometer, and ozone layer is present between 20 to 35 kilometer, containing 99% of the total ozone. In stratosphere, the temperature increases with altitude is due to the absorbance of UV radiation by ozone. The air to be heated, the resulting temperature inversion is what caused the stratosphere to be stable, and pollutants may remain there primarily for many years. The upper boundary is called the stratosphere. So we have discussed that the stratosphere in the stratosphere temperature increase with increasing altitude, and that is reasoned with that with the increase in altitude, the absorbance of UV radiation by ozone. So with this we have done with the troposphere and the stratosphere. So in the next we will start from the mesosphere, that is the third layer of the atmosphere. So our next layer is the mesosphere. We have gone through the troposphere and its characteristics, then we have studied stratosphere, and then now the third layer, that is the mesosphere. The extent of mesosphere is from 50 to 80 kilometers. So temperature in the mesosphere decreases with altitude, with an average temperature reaching -80 degrees Celsius at the top. Therefore, the coldest place on the earth. So if someone asks you which is the coldest place on the earth's atmosphere, you can say that the mesosphere, where at the top of the mesosphere the temperature will reach up to -80 degrees Celsius. So therefore this is the coldest place on the earth. So next layer is thermosphere. The fourth layer, that is the thermosphere, which is extend from 80 to about 500, or you can say above 500 kilometers. So temperature in this layer, that is the thermosphere, increases rapidly due to the absorption of intense solar radiations by the limited amount of molecular oxygen. In this layer, the temperature will reach up to 2000 degrees Celsius. So if you see that in the troposphere temperature was in decreasing trend, and then in stratosphere we have seen temperature increase with increasing height, and then again in mesosphere we have seen that temperature decrease with increasing height, and again in thermosphere temperature increases with increasing height. So in the first layer the temperature decrease with high altitude, in the second layer temperature increase with height, and again in third layer temperature decrease with height, and again in fourth layer, that is the thermosphere, we have seen that temperature increase with increasing altitude and reaching up to 2000 degrees Celsius, that is the hottest place. So in the third and the fourth layer, in the third, that is the mesosphere, and the fourth thermosphere, we have found the another sub layer, that is the ionosphere, so ionosphere is mainly present in between the third and fourth layer, which are third is the mesosphere and fourth is the thermosphere. So we have the ionosphere present in between in between the mesosphere and the thermosphere. So ionosphere mainly extends up to mainly extend from 60 to about 600 kilometers. So few books write that it is extend from 80 kilometer, and few books write that it is from 60 kilometer to 600 kilometers. So based on the standard of the book, you can consult and you can consult the standard book, and you can see which book writes what, and most probably it is written that the 60 to 600 kilometer is the extent of ionosphere. So in this layer, gaseous particles, all the gaseous particles present in this layer absorbs ultraviolet and X-rays from the sun. Now the particles of the gas becomes electrically charged after absorbing the ultraviolet and X rays. So these when these gaseous particle becomes electrically charged, that is in the form of free radicals such as this and this, and radio waves are bounced off the ions and reflects waves back to the earth. This generally helps radio communication. So in the ionosphere we have different ions and radicals. We have different ions and radicals produced due to the absorption of ultraviolet and X-rays by the gaseous particle present in this layer. So once these ions and radicals are formed, these ions and radicals will bounce back the or reflect back the radio waves to the earth. This bouncing back of the radio waves generally helps the radio communication. So based on the height and density of charged particles, this ionosphere further divided into D layer, E layer, F layer and G layer. So the lowest layer is the D layer, which extends from 60 to 99 kilometer or 100 kilometer. Then we have the E layer. We have the E layer, which is from approximately from 90 to 150 kilometers, which is also called as Kenley Heavenside layer. This question will be asked in the multiple choice question in any examination. And the third one is D layer, second is E layer, and the third is F layer, which is about 150 to 380 or 400 kilometers. This is also F2 layer is also called as Appleton layer. And then finally some books write that there is also a G layer. So if you see that these D, E and F layers have their diurnal variation, some diurnal variations which can be seen in this way. So the D layer, basically the D layer, the lowest region present only during the day. It absorbs high frequency radio waves. And E layer is about known as the Kenley Heavenside layer. It reflects radio waves. And we have F layer, the highest, most dense region responsible for long distance radio propagation. It often splits into two layers, that is F1 and F2 layers. So these layers are changing diurnally. The ionosphere is denser during the day due to the direct sunlight and thinner at the night as solar radiation stops. So the density of the charged particles, that is electrons and radicals, becomes high during the daytime when sunlight is there, direct sunlight is there, and then it decreases at the night as the solar radiation stops. So what are the functions and impact of these ionosphere? It helps in radio communication. The ionosphere allows high frequency radio signals to travel around the curve of the earth by reflecting them back to the surface. Then GPS and navigation purpose, space weather and auroras. These auroras are electric energetic particles from the magnetosphere interacts with the region to create auroras at high altitudes. I think in some of the future video we will dedicatedly discuss about the auroras, that is the striking color. Auroras are basically the striking color lights produced in the outer sphere of the earth by the charged particle, interaction of charged particle with the high energy radiation coming from the solar outer sphere. And these are divided into aurora australis and aurora arctics, I think. So in any of the future video we will be discussing about aurora boreals and aurora australis. So with this I think we have done with the different layers of the troposphere. For the summary, I will again summarize these layers. Starting from the beginning, we have the troposphere, which is about 12 kilometer from the earth's face. After that we have the stratosphere, which is up to 50 kilometer, up to the up to 50 kilometer, in which temperature increases with increasing height. And then we have the mesosphere, which is started from 50 kilometer to about 80 kilometer in. And in mesosphere we have temperature profile in a way that decreases with increasing altitude. Then after the mesosphere we have the thermosphere. We have the thermo or the exosphere, in which again temperature increases with increasing height. This is our thermosphere. And we have ionosphere also present in the thermosphere. As we have already discussed, that in the troposphere temperature decreases with increasing height at the rate of 6.5 degrees Celsius per kilometer. So with this I have done with the structure, STRU structure of the atmosphere. Now in next video we will be discussing about composition of the atmosphere. The structure of the atmosphere was mainly mainly troposphere, then stratosphere, then we have mesosphere and thermosphere, right? So with this I think it's enough